Okay.
So we'll start the concept of electric field. Do you have the book opened?
No.
Alright, so it's on page number 1.25,
Yeah.
correct?
From physical significance. No, it's on 1.4.
The heading is at the page
1.4.
1.25, 25 here.
Okay, never mind. It's okay. I got it.
So, what is an electric field? Till now, we have studied about Coulomb's law, right?
Yeah.
It is used to find the force, right?
Yeah.
So, in the force between the charges at rest. Correct?
Yeah.
Now, today we'll study about the electric field. So, what happens is when we have a charge, for consider a charge situated at some point in space. Let's say it's charge Q. Okay. Now, this charge will be imagined to emanate some field, correct?
Yeah.
Will emanate a field just like the magnet. So if you see, if you draw the analogy, you have a magnet, you have north pole and a south pole. And now this magnet has some magnetic field. We cannot see that, but we can feel that. So if you bring another magnet near to it, right, with
Yeah.
north pole here and south here, so there is a range up to which this magnet will attract or
Act.
repel the other magnets, right?
Yeah.
So that range we call as the
Electric
magnetic
field.
field,
Oh, sorry.
right? Actually, they do. They are not concerned about the drawing as yet, but this is just an
Okay.
example. This may be wrong, but like
I think it's more like a.
we
I
do
think it's more
imagine,
like.
right? We do imagine that the point up to which it can attract or repel, the magnetic field will be lying up to that point only, right? For this magnet. So this magnet may not attract a magnet from far away place, right? From here, let's say this is a distance of 10 meters, and this is just a few centimeters. So this magnet will not be having any effect whether this is present or not, because its magnetic field is constrained up to some point, right? So it will not experience any attraction or repulsion from this magnet. Now the same thing happens here, somewhat similar. So what happens is, this is a charge, right? And we know the charges attract or repel each other depending upon the sign of the charges. So if there is another charge, Q charge, plus
Yeah.
Q charge of 1 coulomb, let's say,
Okay.
it is placed in the vicinity of this charge,
Yeah.
and let's say this charge is emanating this electric field.
What does that mean?
I don't know. I read somewhere in physics, emanating just like it's just like the sun emanate the rays, right? So
Uh,
EMANATE.
Become okay, produces maybe like it produces.
Yeah, you can say that. Okay, it produces an electric field all over around it, right? And then we place some another charge plus q of 1 coulomb near to it. Now this charge, let's say this is also positive. So what do you say? This charge, green charge plus q, will be repelled by this charge, isn't it?
Yeah.
But what if you place this charge far away place like this? You place plus q here,
Oh, it won't do anything because it's not in the
it won't
sphere.
do anything, right?
Yeah.
Why? Because the electric field of this charge is constrained up to some distance, right? So what do you observe from this? Like similar in case of magnet, here also in case of charge we assume that there is a electric field around the charge that it creates, right? Up to which it can feel the presence of any other charge around it, correct?
Yeah.
That field is called the electric field. It's very simple, like similar in the case of magnets also, correct?
Yeah.
So the formal definition goes something like this. So if you see in the book, the definition would be there in what is an electric field. So electric field is said to exist at a point if a force of electrical origin is exerted. So that is absurd definition, I think. The electric field definition that is used and you will write in exam is something like this. So electric field is defined as force experienced on a unit positive charge placed at that point.
First one,
I will prove how do this definition holds true. First you write this. So electric field is defined as the force experienced on a unit charge. Unit means 1 coulomb. Force experience, this is the unit charge that we place, right? Okay.
yeah.
So this is the force experienced on the unit charge placed at that point. Now how do we define this definition? Mhm. See in the figure. In the figure, is we call this as the test charge. This charge,
Wait. What did you ask me again?
this I am saying this charge is called the test charge.
Oh no, you asked me a question. I'm like, how do you find this?
Hmm, that was not a question. Like I was just asking.
Oh, okay.
So this is the test charge
Yeah.
that we call it test charge because it is used to calculate the magnitude and the direction of electric field at this point due to this charge, right? Okay.
Yeah.
So that's why it's called a test charge, and the test charge is always 1 coulomb charge. We also call it as q. Somewhere it is written as q naught. Don't mind it. Q naught is also a test charge. Okay.
Okay.
But here
So
we
there are two test charges?
no, like it is the abbreviation or
Okay.
terminology, whatever you say. Some books write it as q, the test charge, and some book write as q naught to distinguish it from normal charges. That's it. Otherwise, it's any charge, right?
Yeah.
It's nothing special, right? It is just a 1 coulomb charge placed at this point. where you want to find the electric field. Okay.
Mm.
So to test the existence of an electric field at any point, suppose this point is P, you want to find the existence of electric field at this point,
Okay, so what does existence mean?
like whether
How
there is
much?
an electric field at all or not. Like if we were to
Okay,
place at this point, then there would not be any electric field, isn't it?
no,
But how do you measure that, right?
yeah, okay.
Like what is electric field?
Like how much?
Yeah, it should have a magnitude, it should have a,
Oh,
yeah,
okay.
isn't it? Because
So
it's,
maybe, wait, I have a thing.
yeah,
Maybe like towards the center, the electric field is like really high, and as it
yeah,
like goes
correct.
down, it's like
Correct,
really
you are
low.
absolutely correct. As we move farther, as we
Yeah,
move farther,
down.
so the electric field will start decreasing.
Okay.
But if you go on to this point, the electric field would be very large. This we'll discuss later on, because the closer the electric fields, the higher is the magnitude. Now at this point, they are farther away from each other,
Yeah.
and at this point, they are very close to each other, isn't it?
It's like a magnet, right?
Yeah, you can. I drawn the analogy already for you.
Yeah.
You can assume it as you place the magnet here also. So if you place at this point, the magnetic field would be very large. If you place farther away,
Yeah.
so it would start decreasing, right? So here also you want to find the existence of electric field at some point P. So what we do is we place a small positive charge, which is called the test charge, at point P, and we say that the electric field is present if we are able to find that this charge is experiencing a force,
Uh, okay.
isn't it? So that's how the definition goes. The electric field is defined as the force experienced on a unit positive charge placed at that point. That's it.
Oh, okay. Oh, this makes sense.
Yeah,
It's like,
it
yeah,
makes sense, because you are, how do you calculate the electric field then? You have to find the force on this charge. If it is present, then
that's,
it would mean that there is some electric field around it.
yeah,
And if it is not, suppose you are placing it at this point, then no force would be experienced
yeah.
on this charge.
Therefore, no electric field present.
Correct? So,
Yeah.
so that's how the definition goes. So this is how do you write the definition exam. This will fetch you 1 mark if it anyway comes. I don't know if it will come or not.
I hope it comes. I hope theory comes. I
So,
hate questions. Okay.
so now we are defining. So electric field symbol is E, obviously capital E with a vector symbol. Why vector? Because anyway it's gonna have a direction, right?
Yeah.
So electric field is defined as what? Force experienced
Uh,
on a unit
oh,
charge divided by that
oh,
charge. Why did I divide? Tell me. The
I
definition
don't
itself
know.
says this, no? You are
Force experienced by a positive charge.
the definition itself is saying all the things. You are finding the force on the unit charge, so you have to divide the force by charge. Okay, so that is Newton per Coulomb. That is because that's a unit charge, no? That's why it is a unit charge that is placed over here. Let us do something different. So what is force? First of all, tell me. What would be the
Force
force?
is KQ1.
K
Q2.
Q Q on R square, isn't it?
Yeah.
And that would be Newton. Now since
Since.
Q is equal to 1 coulomb, so we can safely substitute the value of Q here because capital Q is not known to us, right? The test charge is known to us, that is of 1 coulomb. In order to find the force on 1 coulomb charge, that's what we should do, isn't it?
Yeah.
Because everything else is unknown, right? We don't know the R, we don't know the value of Q.
Yeah.
We
Okay.
just know Q is small q, so why not just substitute it? K 1 Q by R square. What will become? KQ by R
Upon R
square.
square.
So you get F is KQ by R square. Now, here we say electric field is the force experienced on a unit charge. So let us also verify this. What should be the electric field? The total force KQQ divided by R square
Yeah.
divided by Q, correct?
Yeah.
Suppose you are given this, I'm not proving this. Suppose you are given this, the definition of electric field is force divided by charge, correct?
Yeah.
Now we are substituting the values. So force is KQ, capital Q divided by R square divided by Q. So
Yeah.
it would amount to K capital Q by R square. E is K capital Q by R square. Now if you observe carefully, in the first case, what we did, we just did what we knew already. So we just found the force between the two charges,
Yeah.
and then since we knew that Q is 1 coulomb, so we placed the value of Q as 1 coulomb
Yeah.
and got the value of force as this, correct?
Yeah.
Now the definition of electric field says that E is equals to force upon charge.
Upon. Yeah.
And when we did that, we found the value of electric field also to be same as
As.
KQ by R square.
Uh,
Is not that correct to say that the because since we have found this, right?
yeah.
And the force on the unit charge is also found to be this. Force, this is the force on unit charge, isn't it?
Yeah.
Am I correct?
Yeah. Force on the charge.
This is the force on unit charge. And this is what? Electric field.
Electric field.
And they both are same in magnitude, correct?
Yeah.
So can we say that this E is equals to force on unit charge?
E is equals to force on unit charge. Yeah.
Just equate the two. This is the force, like you can also write it in suffix, force on unit charge. What I'm trying to say is that the force on this 1 coulomb charge is same as the definition of electric field that is given in the book, isn't it?
Yeah.
If they both are the same in value, can we say that electric field is force on the unit charge itself?
Yes, we can.
That's what I said, that electric field is force on the unit charge, force divided by charge, correct? Have you got, or are you still
No, I got it.
confused? This is very important to understand.
Yeah, basically, all there is to understand is that force applied on a unit charge is equals to electric field.
Yeah, That's absolutely correct. Because if you
Yes.
don't put it as 1 coulomb, like we generally take this charge as 1 coulomb, right?
No.
That's the nomenclature. That's the test charge. And we find the force on the test charge. So we found the force on the test charge to be equal to kq by r square, which is equal to the definition of electric
Of
field.
electric field.
That means that electric field should be equal to the force that is the unit charge is experiencing. Okay,
No.
so that's what it is. It's very simple. Okay,
No.
so we can safely write it as electric field is equals to force divided by charge. Correct?
Yeah.
That's what it is in the book as well. Now, how do you calculate the direction of electric field? You have found the magnitude. How do you find the direction of electric field?
Yeah.
Can you say about the direction? Would be the
Oh,
same as that of
okay.
force.
No.
So direction, cause is an equal sign and this is a scalar, right?
Yeah. Skip.
So the sign of f should be equal to the sign of e. So that is direction is same as f. Okay, and unit Newton per coulomb.
Yeah. Newton.
And let us do a question now. So mm, can you see?
Um, it's okay. Actually, I got it on textbook.
Okay. So the question is this example 30.
Yeah.
An electron moves a distance of 6 centimeters when accelerated from rest by an electric field of strength 2 into 10 to the power 4 Newton per coulomb. So we are given an electric field of strength 2 into 10 to the power 4 Newton per coulomb. Let's suppose this is the electric field, right?
Yeah.
Now in this electric field, you are placing an electron. So we
Yeah.
placed an electron in here, right? And we know that it's having
Yes.
negative charge, correct? So this electron is initially at rest. This is the first point that is given because it is given that it is accelerated from rest by an electric field of strength this. Now what will happen? See, this electron is free to move around, right? And
Yeah.
when this is placed in this electric field, it will be repelled or attracted. Now you tell me whether it would be repelled or attracted by the electric field.
Mm, attracted.
See, the electric field is going like this.
Oh, okay. Like, will they give us arrows or
That's
a
a
diagram?
that's a different discussion altogether. Because this
Okay, okay. So it will actually repel.
will repel or attract.
It repel.
Repel.
It
See,
will repel.
I'll tell you this tomorrow.
I don't know because I saw somewhere that the electric field of a positive charge.
Yeah,
Wait, actually, I forgot. But like the electric fields of the positive charge is like the arrow is like
that's why
inward.
that's why this that's a different discussion now. So there are
Um,
two types of fields. One due to
am I
positive,
right though? Am I
yeah,
right though?
other due to negative.
But am I right? Will
Yeah.
it attract?
No, but I'll
Please let
tell you
me know.
tomorrow, na, because that's a different topic.
No, but like for this one, will it attract?
For this,
Yeah.
okay, so electric field is going like this. If we assume it's going outside,
So will
correct?
attract.
And this
I
is
mean, wait. Well, I don't know. I forgot. I
see,
can't
I'm telling you, no, if this is going outward, then the charge situated here should be positive charge only.
Oh, okay.
Okay, and if this is positive and this is negative, then it will be attracted.
Just made me even more confused.
Why?
If what will be positive and what will be negative, it will be towards inside.
Yeah, see, generally you will get an electric field that is outside, right? And an electric field that is outside will be created by a charge that is positive. It's nothing given here, it's not a concern. I just asked you randomly. Because electric field can be created by positive as well as negative charge. Okay.
Okay, so this one will be attracting the electron.
Yeah, but if it is plus Q charge,
Yeah.
then it
Then
would
it
be
will be
repelled.
repelling. Yeah.
This is the odd case, na? Here electron is placed.
Geo.
That's why you may be confused. If plus Q charge is situated, then it would be repelled. Actually, there is a point, if you note it, that might come in tomorrow as well. So if you want to find the direction, direction of electric field, correct?
Yeah.
If you want to find the direction of electric field, it is the if you put a positive charge in here, plus Q charge, okay,
Yeah.
and then second step is find force direction towards CE, force direction on that charge. That will give you the direction of electric. Suppose, let's say you are given something like this. This should also be some magnetic field. Okay,
Yeah.
right? You want to find. Suppose you place Q here, plus Q.
Okay.
So plus Q charge will be because we generally place the test charge that is positive.
Mhm.
Test charge is always positive. Now the electric field direction is this. Okay. So the rule of thumb is that the plus Q charge will move in the direction of electric. Let it mark in the different pen. This is the rule of thumb. The direction of electric field is same as the direction
The
of force
direction
on this
of.
positive charge.
Okay. Oh,
But this will be discussed tomorrow. This is electric field is a far more bigger topic now. This will take some lectures.
oh my god,
Yeah.
this is a long chapter.
This chapter itself is, I think, will take. This is the longest. Okay.
Oh, okay. Now there's like, oh my god. Like,
Unit I'm talking about. Chapter might be small, like there are many chapters in this unit, right? But unit itself is very big. Like it might take 2 months or
well, what?
yeah. This is
How many units are there?
units are not that like units might be I think
2 units.
no in NCRT they are giving chapters. Okay,
Oh, okay.
I'm talking about with regard respect to this book.
Oh, okay. So like in this book, there's
So I have not downloaded everything. Na? This is the first one that I've downloaded.
okay.
But with respect to the syllabus, we always look at the NCRTs.
Okay, okay.
This is just to read and study.
So like I think this is going to take like a whole month to finish.
Might take. Oh no, why do you care?
I care because I have free boards.
Keyboards like would be in December or something.
Yeah, November, December.
Don't worry, complete it.
Okay.
Sorry. So
You're so
the point here is that we are given an electric field. You can also draw electric field like this. Why draw the circular one? Okay. You are given
okay.
electric field of strength 2 into 10 to the power 4 Newton per Coulomb, and you placed an electron here. Okay.
Yeah.
Now tell me in which direction this electron would move.
Opposite.
Yeah, very good. Opposite direction. Because positive charge would be moving in the same direction as electric field.
Yeah.
Then the electron should move in the other direction. Correct?
Opposite. Yeah.
So it is at rest. Now it will experience a force, isn't it?
Yeah.
It will move. That means it is experiencing this force from the electric field. We need to find what we need to find. Okay, so it is given that a distance of 6 centimeters is traveled. So let's suppose this is from here to here. This is 6 centimeters. Correct?
Yeah.
What happens later we don't know. The question is asking up to this point, up to 6 centimeters from A to B. Okay, and he's asking the time of travel. So we want to find time taken to travel from A to B. That we need to find.
Okay.
Okay.
Yeah.
Now, since this is experiencing a force, so the motion. So you can write since electron is experiencing force. So the motion would be accelerated motion. What do you say?
Yeah.
Because force is accompanied by acceleration always. Force is equals to mass into acceleration, isn't it?
Yeah. For yeah.
When you have force, the motion would not be simple uniform motion. Okay, the motion would be accelerated. So equation of motion would come into picture here.
Oh, like V1 minus. I mean V2 minus
Yeah,
V1.
so uh, all of them, three equations are there.
Oh
You
yeah.
can apply anyone as per convenience. We need to find t here. That is the question. Okay,
Yeah.
so we are given electric field, right?
Yeah.
We are given the electric field. We are given the mass of electron, and we are given the charge on electron as well. Okay, so
Yeah.
those things are also given to us. Now we want to find time. So the time is given by the first equation and the second equation, correct? The third equation does not have time in it. So if we use second, which is
Okay.
ut plus half at square, correct?
Yeah.
Oh, sorry, this is s. So s is equals to ut plus half at square. Now since u is 0 because rest is the initial condition of the electron, correct, isn't it?
Yeah.
This u is 0, so ut would be 0, so s is equals to half at square.
Square. Yeah.
This s is given to us 6 centimeters, correct?
Yeah. Which equals to
This
half.
t we want to find and we don't know this a.
Yeah.
Okay, now
Yeah.
how do you find this a? You tell. We can find a using this. Okay, force is equals to mass into acceleration, so acceleration would be how much? Force upon mass.
Force upon mass. Yeah.
Mass is given,
Yeah.
but force again is not given.
So we
Okay,
probably put like some other
so
form.
how?
Oh, we use the Q upon.
No, we use this. We
Which
use
one?
electric field is equals to force upon charge. So
Upon Q.
force
Yeah.
would be how
Makes sense.
much? Electric field
Force.
into charge from here, from this equation.
Yeah.
You can call it equation 1. So from equation 1 we can call it E into Q
Yeah.
divided by M from
Equation 1.
equation 1. Now you have everything. Electric field is given to us.
Yeah.
Q is given to us, the charge of electron.
Yeah, and the
Mass
mass
is
is also
given to
given.
us. And we want to find the magnitude here. So take everything as magnitude. Okay, we are not concerned with the direction of the acceleration here.
Okay.
So it would be, let us substitute in the values.
No, it's insert, not update.
1.6 into 10 to the power minus 19 coulomb is the charge. And what is the electric field? Can you tell me?
2 into 10 raised to the power 4 Newton per coulomb.
Okay. So if you solve this, I will not be solving it. This would amount to, what it would amount to?
0.35
into 10 to the
10 raised to the
power
power 16 meter per second
16
square.
meter per second square. This is a magnitude,
Okay.
correct?
Yeah, and now we substitute that
And
in.
now from substitute value of a in S, what it would be? 6 is 0.06. Don't write 6 because we need to use SI units. 0.6 meters is equals to half into a
0.35 to 10 raised to the power 16 meter.
into t square. So here you can find t, right?
No.
It will come out to be 1.25 into 10 to the power minus 7. So small. It moved 6 centimeter in this much time.
Oh.
Now you can deduce something from this question. You can see that the electric field can make a charged particle move in accelerated motion.
Yeah.
Okay. The charged particle is placed in the electric field. It would start accelerating. Okay.
Yeah.
Like there is no force physically. Okay. But the electric field is there, no? That's why a
Yeah.
body would move.
So, like, does every charged particle have an electric field?
Yeah, any charged
Yes.
particle has an electric field. Any charged particle would be having some electric field of its own. Alright.
Yeah.
So this is question 30, example 30. Have you got how we get the answer?
Yeah.
Okay, so time is also getting over, no?
Yeah.
I'm also not feeling well today.
Oh, what happened? Not to work, just you.
Like I'm sick partially.
Partially, what is that? So like you got a sinus again.
Not that. I don't know. I'm not feeling well. Just
Maybe you aren't eating properly.
I will, like there is
Well, are you feeling like homesick?
not that sick. Really sick.
No, get well soon.
But it's very hot, in Delhi. I don't know about Bangalore.
No, it's not hot. It's cold. Well, maybe you might want
It's
to.
very hot here. You cannot switch off the AC at any point in time.
It was like 30 over here in April.
Oh,
Yeah, like during Ramadan, and we were sweating like crazy.
you are living in almost Jannah,
No, you can't say that. Yeah.
but Bangalore's weather is very good now.
Yeah, except for April.
Okay.
That's like hot.
Oh, so we will start tomorrow. Okay.
Okay.
Uh, did I
Oh
give
my god,
you?
I didn't write anything.
You can write. Meanwhile, okay. You didn't do the third question that I gave you.
For which? For physics?
Physics, you're not.
Yep, and then we did it yesterday in class. No, day for yesterday in class, remember? The square one.
You're not sent me or neither explained me the solutions.
Oh, the explanation. I'll explain it to you tomorrow, I promise. Oh, let me go.
Okay, so we'll discuss again. Start discussion from today's leftover,
Okay.
so that you get a proper understanding of this.
Okay, can you scroll up? Because do I need to write the thing, this diagram?
Yeah, I can write, or maybe probably you can understand from the book. That's very good if you can. From the book, if you can understand. I don't know. Oh, I can share it. So
What's weekend? It's Friday.
I share the link.
Okay. On Telegram?
What diagram?
Telegram. On Telegram.
I'm sharing the link of the whole
Okay.
presentation now. This diagram are you talking about? The magnet?
No, I was like, are you going to share the link on Telegram?
Yeah, on the telegram. Oh, I thought it is you're saying
No,
diagram.
no.
I've shared on telegram. You can check right now. You can access.
Also, you're right. Telegram,
I shared you.
no, got it.
Got it. Is it visible? Like
Do you teach coding?
no. Like I know coding. Have you got somewhere?
You put like the output is red, this is red, this is pink, this is yellow.
Where?
It's in section 1.
Oh, let me see. I don't know. Oh, it's all shared. I don't know. Let me see what I've written. Do you want to learn? Oh yeah. No, that's terrible. That's not coding. That's Do you call it coding? I'm not getting your voice. Okay, then that's all for today.